In this episode, we are going to make a difficult group of Windows problems much easier to sort out by focusing on what the symptoms are really trying to tell you. For a beginner, service startup failures, low memory warnings, and missing operating system (OS) messages can feel unrelated at first, but they all point to the same bigger skill, which is learning to tell whether Windows is struggling because of startup configuration, storage trouble, memory pressure, or damaged system files. When a user says the computer is acting strange, that could mean almost anything, so the technician needs a way to break the problem into smaller parts instead of guessing. The good news is that these problems become much more manageable when you look at when they happen, what part of the system is affected, and whether the issue seems tied to the startup path, the running environment, or the files Windows depends on to function correctly. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. A strong first step is to understand that these symptoms do not all happen at the same time in the life of the computer. A missing OS message appears very early, usually before Windows has a chance to load normally, which tells you the problem is happening at the startup level. A service startup failure usually appears later, when Windows is already loading or has reached the desktop, but specific background functions do not start as expected. Low memory warnings happen after the system is running and trying to keep up with too much demand or too few available resources. That timing matters because it keeps you from mixing every symptom together into one mystery. A technician who notices when the problem appears already has a much better chance of tracing the fault to the right area, whether that means boot configuration, storage access, memory pressure, or Windows components that are no longer loading the way they should. Services are one of the most useful parts of Windows to understand because they are background functions that help the system and applications operate properly. Some services support printing, some support updates, some help with networking, and others help the system manage security, accounts, or other important tasks that users do not always see directly. When a service fails to start, the user may not say the word service at all. The user may just report that printing stopped working, updates keep failing, the network acts strangely, or a program opens but does not behave normally. For beginners, the key point is that a service startup failure is often not the whole problem by itself. It is a sign that one part of Windows or one dependent application did not get the background support it expected. That means the technician should think about what function is missing and whether the failure is isolated to one service or part of a broader startup issue. A single service failure often points toward a more focused problem than a missing OS message or a low memory condition. If one function stops working while the rest of the system seems mostly normal, that suggests the startup path of Windows may be fine overall, but a background component is failing for some reason. That reason could be a service set to the wrong startup type, a dependency that never started, a recent change that interfered with the service, or damage to files tied closely to that feature. Beginners do not need to memorize every service name to make progress here. What helps most is noticing the pattern. Is only one feature broken, or are many background functions failing together? If it is only one, the technician should think more narrowly. If several services fail at once, then the picture becomes bigger, and the technician may need to consider whether system files, storage, or broader startup configuration problems are preventing Windows from loading normal background activity correctly. Startup configuration matters because Windows depends on many settings and paths that tell it what to load, when to load it, and how different parts depend on one another. If a service that should start automatically has been set incorrectly, or if a service depends on another one that failed first, then the visible symptom may be the later failure even though the root problem sits earlier in the chain. This is one reason beginners should avoid fixing service problems by simply restarting random items until something appears to work. That approach may hide the deeper issue without solving it. A better way to think is to ask whether the service failed by itself or whether something it depends on never came up correctly. When a service fails, the technician should think about order and relationship. Windows is full of parts that rely on other parts, so a missing background function may be the result of one broken step earlier in the startup process rather than one broken feature acting completely alone. Low memory warnings create a different kind of problem because they appear after Windows is already running and trying to do more work than the available memory can support comfortably. For a beginner, the easiest way to understand memory pressure is to think about workspace. The system needs room to keep programs, data, and active tasks available quickly. When that room starts to run out, Windows may slow down, display warnings, freeze, or close programs unexpectedly. Users often describe this in very simple language. They may say the computer is crawling, everything is hanging, or applications keep refusing to respond. Those are good clues because low memory problems often feel like the system is still alive but struggling badly to keep up. Unlike a missing OS message, which points to an early startup path problem, low memory conditions usually show up during regular use, especially when many tasks, large files, or demanding applications are active at the same time. A technician should also understand that low memory warnings are not always only about physical memory itself. Sometimes the problem is straightforward, such as too many demanding applications running at once on a system that simply does not have enough memory for that workload. Other times the warning reflects wider resource pressure, where the computer is using storage to help make up for limited memory, and that process is also becoming strained. For beginners, the important lesson is that low memory symptoms often grow out of workload and system capacity meeting each other in the wrong way. If the user has 20 heavy browser tabs open, several large programs running, and too little free room to handle all of it smoothly, the computer may begin acting unstable even though nothing is infected and nothing is missing from startup. Memory pressure is about the system running out of room to think and work efficiently, and the symptom pattern reflects that strain. This is where storage and memory start to overlap in a way that confuses many beginners. A low memory warning may sound like the trouble must be purely about installed memory, but storage can matter too because Windows relies on available space and healthy storage behavior as part of how it manages running workloads. If storage is nearly full, unusually slow, or beginning to fail, the system may struggle more when memory pressure rises. That can make the computer feel like it has a memory problem even though storage health is helping make everything worse. The reverse can happen too. A system with limited memory may put extra pressure on storage during normal use, and that can slow the whole machine enough that users blame the drive first. The technician's job is not to guess based on one warning alone. It is to notice whether the strain seems tied to too many active tasks, too little free capacity, unusual storage delays, or a broader mix of resource pressure that is affecting the whole machine. A missing OS symptom points much earlier in the startup path and should immediately make a technician think about whether the computer is finding the right storage device and the right startup information at all. When a machine says the operating system is missing, the computer is not telling you that one app failed or that the user opened too many windows. It is telling you that it cannot find or use what it needs to start Windows in the expected way. For a beginner, this is a very useful distinction because it removes a lot of confusion right away. This is not a desktop problem, not a user profile problem, and not a low memory problem. It is a startup level problem. The fault may be with storage not being detected correctly, with startup order pointing to the wrong place, with damaged boot information, or with more serious drive trouble that has made the needed system content unavailable when the computer first tries to begin. Storage trouble becomes one of the strongest possibilities when a system reports that the OS is missing, especially if the machine previously worked and then suddenly began failing to start. A healthy drive should be available when the computer looks for it, and the needed startup information should be readable. If the drive is disconnected, failing, or no longer responding correctly, the startup process may stop before Windows has a chance to appear. For beginners, a good way to think about this is that the computer cannot start what it cannot find. That does not always mean the whole drive is dead, but it does mean the path to Windows has been interrupted somewhere important. This is why technicians should pay attention to any signs that the storage device has been unstable, that the machine was dropped recently, that strange noises have appeared, or that the system had trouble saving or reading files before the startup failure began. Those details can help connect a missing OS symptom to a likely storage cause. Startup configuration is another major possibility when Windows appears missing even though the storage may still be physically present. The computer has to know where to look first and what to treat as the correct startup target. If that configuration has changed, become damaged, or been pointed to the wrong device, then the machine may behave as though Windows is gone even when the data is still sitting there. Beginners should understand that startup configuration acts like a map. If the map is wrong, the computer may not reach the right destination even though the destination still exists. This is especially helpful when a problem begins after a settings change, new hardware, a recent update, or work done on the storage layout. A technician who keeps startup configuration in mind is less likely to assume the drive is permanently dead the moment the error appears. Sometimes the path is broken even when the data itself has not disappeared. System files matter because Windows depends on a large set of core files to start properly, run services, manage resources, and support the normal desktop environment. If those files are damaged, missing, or corrupted, the symptoms may look different depending on where the damage sits. Damage in the startup path may lead to boot failures or missing OS behavior. Damage in files tied to services may lead to startup failures for specific functions after Windows loads. Damage in broader system components may create instability, freezes, or strange behavior that grows worse over time. For beginners, this is where the topic becomes easier to connect. The same general idea, damaged system files, can appear in different ways depending on which part of Windows is affected. That is why technicians should not stop at the visible symptom. They should ask what layer of the system seems unable to do its job, and whether file damage might explain why that layer is no longer loading or behaving correctly. Recent change is another clue that helps beginners sort these cases more calmly. If service failures began right after software was installed, if low memory warnings appeared after the user changed how they work or loaded several new programs, or if a missing OS symptom followed hardware work or a sudden system interruption, those details matter. Timing does not prove the cause by itself, but it gives the technician a much stronger direction than random guessing. Good troubleshooting often begins with very plain questions. What changed? When did it change? And what was the first sign that the system was no longer normal? In many cases, users say nothing changed because they did not think the update, new app, storage move, or forced restart mattered. The technician needs to listen closely and keep asking in simple terms until the timeline becomes clearer. Once the timeline makes sense, the fault is usually much easier to connect to startup configuration, storage, memory pressure, or system files. It also helps to explain these symptoms to users in a calm way because the messages often sound worse than they really understand. A missing OS message makes many people think every file is gone forever. A low memory warning makes some users think the computer has a virus or that the hardware is permanently ruined. Service startup failures can make users assume the whole operating system needs to be replaced when the issue may be much narrower. A technician should help by translating the symptom into plain language. The computer may be unable to find Windows right now. The system may be overloaded and short on working room, or one background function may not be starting properly. That kind of explanation lowers panic and makes the next steps easier. Support work gets much better when the user understands that the symptoms point to different system layers and that those layers can be checked one at a time instead of all being treated as one giant disaster. As we close, the biggest lesson is that service startup failures, low memory warnings, and missing OS symptoms are much easier to solve when you sort them by system layer and timing. A missing OS message points to startup configuration or storage access very early in the boot path. Service startup failures usually mean Windows has loaded far enough to reach the desktop or near the desktop, but one or more background functions are not starting as expected. Low memory warnings show up after the system is running and usually mean the computer is under resource pressure, which may involve too many active tasks, too little available memory, or storage strain, making the problem worse. Damaged system files can affect all of these areas depending on where the damage sits. For a beginner, that is the main takeaway. Do not lump every strange Windows symptom together. Ask when it appears, what layer it affects, and whether the better answer points to startup configuration, storage, memory pressure, or system files. Once you make that separation, the problem becomes much clearer and much less intimidating.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.